Alright, welcome back. In this video, we'll take a look at how to work with events in WxPython. We will also be creating a simple input form and a unit converter where we will work with input widgets as well as events in WxPython. To start, we will first look at how to work with events in WxPython, and you can find the starter code here in the GitHub link in the description below. We will first create a button using WX.button. And this expects a parent which we'll pass in as the panel. Let's also give it a label of click me, for example. And I'll increase the size a little. Alright, so now what we want to do is to be able to listen to whenever the user clicks this button and run a function, for example, where we can have all the functionality inside that function. So the way we do that in WxPython is that we first use panel.bind. Then we need to specify the type of event we want to listen to. In this case, we want to listen to whenever the user has clicked on the button. And we can do that by passing in the option of wx.evt_button. And this event will be sort of emitted whenever the user clicks on a button within our application. The question that you probably have now is, how would you know that it is wx.evt_button? And one of the ways you can find out the available events that you can use is by going to the WxPython documentation. You can search for the button widget. And under the available events, we can see that this is the event that is dispatched whenever a button has been clicked. Besides just specifying the event, we also need to specify a handler, which is a function that will be called once the event has occurred. In this case, I'll just make a simple function above before we bind it, and it'll just print something to the terminal. This is where you can have any functionality, and we will look at adding more functionality at a later stage in this video. And we'll then need to pass a reference to that function within the handler. Note that we should not call it immediately, since this is a function that will be called automatically by WxPython once the event has been called. So we just need to pass in the reference, but not actually call it. Lastly, we also need to specify the source so that WxPython knows which widget we are listening to. And in this case, we will just pass in the button variable that we assigned when creating the button widget. So just make sure that whenever you bind an event, you need to pass in the event, the handler that you want to be called once the event has occurred, as well as the source of the event. And that's one of the reasons why we need to use app.main loop. It's so that our application can run an infinite loop, and whenever an event has occurred, such as the user clicking a button, it can dispatch the necessary event handlers. But if we run our application now, it still won't work. The handler is not executed as expected, and that's because it is being given one argument, but it is accepting 0 arguments. So what actually happens here is that whenever our click handler method is being called, it is given an event object, and this has some details such as the event category. And you can see the full list of methods and properties that you can use on the event object within the documentation, which I'll link below as well. But that's not something we need to do right now. So we just specify the argument but not use it. And if we run our application now, we can see that the function is being executed correctly whenever we click the button. Alright, and before we look at how to create an input form that allows the user to enter input, we will first look at a way to organize our code better. Especially because right now we have just a function being randomly placed within our script. And usually a much better way that you see code being organized when you're making a WxPython application is using a class. And a class in Python allows us to create our own objects that have their own methods and attributes, similar to how we are using wx.panel and wx.frame, which all have their own methods and attributes. And within this class, we will create all of the widgets and functions that we will need for our application. So we'll first start by commenting out our code that we have previously. We will then create a new class called MyButtonPanel, and we will need to inherit from wx.panel. This will allow us to use all of the functionalities and methods from wx.panel, but also add our own ones, and we can do it like so. Next, we will create the method that will be called to create a new instance when we are using this class, which we can do like so. And this object will receive self, and that refers to the instance that is being used. Since we are inheriting from wx.panel, we will also need to initialize it, which you can do by using the super method and then using the initialize method. So what this will do is that whenever we initialize a new instance of our class, it will first initialize a wx.panel class, but on top of that we will add our own widgets within this panel. Let's also pass all of the arguments that we use to initialize our object to wx.panel when we are initializing it. And the way we do it is like so. We specify an asterisk and the variable called args, and this will allow us to accept any number of arguments which will be packed into a list. And we do something similar for the keyword arguments, only this time we are using two asterisks, and then we'll pack the keyword arguments into a dictionary, and we can then unpack it when we're initializing wx.panel by using an asterisk for the arguments and two asterisks for the keyword arguments as well. We will then create the button that we need like we did previously, but this time instead of specifying the parent as the panel object, since we are creating our own class and we have inherited from wx.panel, we can just specify self as the parent. We will then also specify the same label as well as the same size. Now that we have created our own class, we can create the click handler as a method within our class like so. And since this is a method within our class, it will receive a self argument whenever it is called, and that refers to the instance that is being used here. And we will also accept the event argument, although we are not going to use it. And I'll just print something to the terminal like we did before. And then use self.bind to bind the event handler to an event. And I'm using self.bind here instead of panel.bind because self refers to our panel in this case. And I'll also specify the handler self.clickHandler since it is a method within our class, and the source as the button. And just before we run our application, we will need to create an instance of our button panel, which we can do like how we normally initialize our wx.panel by passing in the frame, which is the parent that we want to use. And if we run our application now, whenever we click the button, our event handler is being executed correctly. So you might be wondering why we need to create a class and go through all of this trouble when the result is the same. And the reason is because writing our code this way is much more organized, and that isn't obvious right now, but when we look at how to create the unit converter later, having a class to organize our code, it looks much better and it's much more readable. And this is how most WxPython applications are written. So knowing how classes are written this way will allow you to understand how other people's code work better. Alright, we'll now take a look at how to create a simple input form. Within this form, we will have a few radio buttons as well as a combo box and a submit button. And this will allow us to see how we can receive user input from our WxPython application. So to start, I have just some starting code here. This sets up the layout that we will need so that we can focus on creating the widgets as well as receiving the user input using events. If you are interested in learning how to create layouts to lay out your widgets in WxPython, I've covered that in the previous video in this tutorial series. We will first start by creating the radio box. This expects a parent, which will pass in as the self variable, as well as a label as the title of our radio box. I'll just make this a radio box about choosing a color. And to pass in the radio buttons that we want, we'll need to pass in a list of choices. In this case, I'll just give 3 colors. Now for specifying the orientation that we want to use, we can specify that as a style keyword argument. And we can use wx.horizontal or wx.vertical for the orientation. I'll go with wx.horizontal. What I also need to do is to make the radio box variable an attribute of our object here. This is so that we can reference and use it later on in other methods within our object, such as when we need to get the value within our event handler. If we do not do this, we can only access the radio box variable within our initialization method. I'll then create the submit button, which you have seen before. And I'll give it a size of 100 by 30 as well. And I'll just comment out the code that is used to add the combo box to the layout, because we'll take a look at that later. Finally, we also bind the button event. To a submit handler, which I'll create in a moment, so that it is called whenever the button has been clicked, and I'll specify the source as the submit button. Now within this submit handler, I'll just print out whatever the user has selected for our radio boxes. And we can do that by using self.radiobox.getStringSelection. And this will return the string of the value of the radio box that has been selected. For the radio box, there are other methods such as getting the column count or setting the default value of the radio box, which you can find within the documentation. But for now, we'll just need to get the string that has been selected. If we run our application now, we can see that whatever the user selected for the radio box will be printed to the console once they have clicked on the submit button. The next thing that we'll look at how to do is to create a combo box. This allows the user to select from your drop-down menu. This can be useful if you have multiple options and you do not want to show all of them to the user at once, compared to a radio box where all of the options are immediately visible to the user. We can create it by using wx.combobox. And we'll specify the parent as the self variable. And we can also specify the choices of the drop-down menu within a list. I'll just make this a combo box for the user to select a programming language. And now comment out the code below to add the combo box to the layout. And if we run our application now, we can see that with a simple drop-down menu. But something that you might also want to do is to set a default value. And for our combo box, we can do it by using self.combobox.setSelection. And we can set the default value by entering the index of the list of choices that we have passed. So for example, if I wanted the second option to be the default value, I'll pass in 1 as the argument here. And also print the user selection when the submit handler has been executed, which you can do by using getStringSelection as well. And so now whatever the user selected for the input widgets will be printed out once they have clicked on the submit button. And something that we should also do to improve our application is to add a label above the combo box so that the user knows what it is for. So we can do that by quickly just using a static text to create some text. And I'll then add it to the layout that we have here. I'll specify a flag of WX.all and a border of 10 to add some spacing around it. And now we have a basic form application that allows the user to enter some input, and we are able to collect that data, which we can then use to, for example, add to a file or a database, which we will look at how to do in a future video. Alright, we'll now create a simple unit converter that converts kilometers to meters as well as meters to kilometers. You can find the starter code for this application and the GitHub link in the description below. But I've essentially created the layout already so that we can focus on creating the widgets and working with user events and the input widgets to be able to display the correct output. And just as a side note, the output text control here has a style of read-only so that the user cannot enter anything, so it is just used as something to display the output to the user. There are a few other options such as using key_password if you would like to use a text control for the user to enter a password so that what they have entered will be hidden as asterisk. And if you run the application, there will be just a simple application with the input for the user to enter a number and two radio buttons for them to select the type of conversion, as well as an output that will automatically display the calculation once the user has changed their input. Alright, I'll first start by creating a calculate output method, and this method will be called whenever the user has changed their input. And to start off, first just print out whatever the user has entered into the input text control, which you can do using the getValue method. So now we want to call this method whenever the user has changed the text within the input text control. And the event we are listening to in this case is the EVT_text event. And you can find out more about that within the documentation. There are a few others for the text control as well, but the EVT_text event will be a method whenever the user changes the text. And I'll bind it to the calculate output event handler here. The source here being the input text control. If we run our application now, whenever we change the text within the input text control, the value that we have entered will be printed to the terminal now. So to be able to calculate the output, we first need to store that value, and I'll convert it to a float so that we can work with it as a number. And the reason why I'm not converting it into an integer here is because if the number has decimal places, then we will run into an error. We then want to calculate the output based on what radio button the user has selected. So in the first scenario, they will select kilometers to meters, which you can check by using the getStringSelection method. So if it is, we will just create a new variable called the output value, and that will be the input value multiplied by 1000. Now then set that value to the value of the output text control. But if we run that now, we actually run into an error, and that's because the set value method expects a string, but we have given it a number here. So the way that we get around that is that we first convert it to a string. And now whenever we change the value for the input, the output will automatically be calculated for the first option. But here we run into another problem, which is that when the user enters a value that isn't a number, our script throws a value error since it is not able to convert it to a float. What I want to do here is that whenever the user enters a value that isn't a number, we display a text telling them to please enter a valid number within the output text control. So we first need to know there is a value error, and the way that we do that is by using a try and exam block, which we can do like so. So here we first try to run this part of the script, and if it runs into a value error, then it will execute this part of the script, and within this part of the script I'll then just set the value of the output text control to an appropriate error message. And now our application will still be able to work correctly even if the user enters an invalid number. So now the other possibility is that the user selects meters to kilometers, and we can handle that within an else block since it's either kilometers to meters or meters to kilometers. And in that case, the output value will be the input value divided by 1000. I will also round it using the built-in Python method round to be able to round it to 3 decimal places, which you can specify as the second argument. Once it has been calculated, we can then set it the same way like we did above. And since we are setting the value of the output text control in both cases, what we can actually do is to just move this part of code out of the if statement. And so now we will first receive the input value and store it, and within our if statement we will calculate the output value, and in both cases we will set the value to the output text control once we have calculated the output value. If we run our application now, it is able to calculate the correct output on both kilometers to meters as well as meters to kilometers. But the problem now is that whenever we change our selection without modifying our input value, the output value is not recalculated. And that's because our event only listens to changes within the input text control. So the way that you can get around this is to also listen to an event whenever the user changes the selection on the radio boxes. So we will bind an event. In this case, you will need to use evt underscore radio box. And within the documentation, we can see that this event is emitted whenever the user selects a new radio box. So I'll bind it to the same calculate output method, and the source being the radio box, so that the calculate output method will be executed if either the user has entered some new text within the text control, or if they have selected a different radio button within our radio box. Alright, and now we have the completed unit converter. Feel free to experiment with the different colors for this application or different types of events, but I'll leave it as so for now. Alright, and for this last part, I'll quickly show how you can work with mouse and keyboard events. This will be really useful when we work on a painting application using WxPython in a future video, but I will still showcase it within this video since this is about working with events in WxPython. So to start, you can also find the starter code and the GitHub link in the description below. To receive mouse events, we can use south.bind and use the event evt underscore left underscore down. Left meaning the left mouse button, and down meaning the user has pressed down on the button. I'll then bind it to an event handler called clickHandler, which I'll create below. And note that when we're working with mouse and keyboard events as well, we do not need to specify a source, since we are trying to listen to a mouse event regardless of where the user clicked within the application. And within our clickHandler, we can actually make use of the event object that is being passed down, using the getPosition method to receive the coordinates of where the user clicked on within our application. And so if you test it out now, whenever the user clicks on some part of our application, the coordinates will be returned as a tuple using the getPosition method, as you can see. And for keyboard events, the way we receive them is using the evt_key_down event, and I'll point that to an event handler called keyDownHandler. The way that we find out which key the user has pressed on is using the getKeyCode method on the event object, and this will give a number that is associated with the key that the user has pressed on. For example, if I press on W, that will return a key code of 87. So the way that we check if a user has pressed on a certain key, for example W, is you can just check if the key code is equals to 87, for example. Alright, and that's about it for this video. If this video has helped you, or if you've enjoyed this video, please consider liking this video and possibly subscribing as well to see more of such content and to help my channel out.